Hello, ladies and gentlemen. Welcome back to Math 30-1, Chapter 4, Section 4, Determining Restrictions on Composite Functions, Part 2. Now, here, once again, we're usually looking at the domain. Occasionally we ask about the range, but that's usually a graphing problem. But algebraically, we talk about the domain, and that's what I expect you to know. So, let's move on to the nasty ones. F of x is the square root of x minus 6, and g of x is x squared minus 5x. Now, find g of f of x. And remember, I will write that as goff of x just to confuse you with a hollow dot. So it's a composite function, not a multiplication. So first thing is we put in f of x, square root of x minus 6, goes into g of x. Oh, sorry, in this case it should be blue. So this becomes square root of x minus 6 squared minus 5 times square root of x minus 6. X minus 6 minus 5 square root of x minus 6. That you can graph. Now, I want you to note here, of course, well, not of course, but you should go, oh, wait a minute. X minus 6, don't you use this toy, go away. X minus 6 has to be greater than or equal to 0, so x has to be greater than or equal to 6. That's a restriction on this function. Okay, so that restriction continues down here, semicolon, x is greater than or equal to 6. Now, that's kind of obvious because x minus 6 is here. But what happens if it disappears? Like in this example here, g of f of x, where f of x is root of x minus 2 and g of x is x squared plus 3. Once again, g of f, goff of x. F of x is the root of x minus 2, and that goes into g of x. So that becomes square root of x minus 2 squared plus 3, which is x minus 2 plus 3, or x plus 1. So far, so good. Now, of course, the trick. X minus 2 has to be greater than or equal to 0. X is greater than or equal to 2. That restriction continues. This only works when x is greater than or equal to 2. It does not exist on, when x is less than 2. And I want to stress this, the restriction continues. Okay. So far, so good? Well, I hope so. Now, let's move on to the nasty one. F of x equals root of x minus 6, and g of x is x squared minus 5x. Seen that one before. Find fog of x, which is f of g of x. I'm writing them both ways just so you get in the habit of seeing them and remembering them. So g of x is x squared minus 5x, and f of x, that becomes the square root of x squared minus 5x minus 6. You're going, oh god, another square root, but it's also quadratic. And that you can factor. That is x minus 6, x plus 1. Sorry, had to think there for a sec. You're supposed to be able to do these simpler ones. I should be able to do in my head, but I can't. X squared minus 5x minus 6. Two numbers, this has to be x, this has to be x. Two numbers that multiply together to be minus 6, but add to be minus 5, be x minus 6 and x plus 1. That's what I did. Now, what's happening here is important. We have x minus 6 equals 0, or x equals 6. Normally we would set this equal to 0 and solve. Now we're finding critical points. The other critical point is x plus 1 equals 0, or x equals minus 1. Now we call it a critical point because if we graph this parabola, the original function is, oh, sorry, drew it wrong. Will look more, sorry, my parabola will look more like this, minus 1 plus 6, and down here at minus 6. So the original parabola goes like this. Now, the problem is we're taking the square root of that. So you think back to chapter 2, critical values and radicals. So when y equals 0 and y equals 1, we get our invariant points. So I should have an invariant point there, and there, and there, and there. And that is at 6 exactly, not close to 6. Now, when you take this, sorry, I want to stress this is y equals x squared minus 5x minus 6. The radical, the root of that, will be like that. How do I know that? Well, you can't take the square root of a negative value. So everything between minus 1 and x equals minus 1, x equals plus 6 doesn't exist or doesn't work. So here my domain, negative infinity, comma, minus 1, comma, 6, comma, infinity. And that infinity looks horrible. Or x is less than or equal to minus 1, x is greater than or equal to 6. Yes, that you should remember from chapter 2. Now, these critical points are the x-intercepts, what you should be able to find. Now, I did it algebraically. This one you can graph, you can find it graphically. I'm fine with that too. And before somebody starts whining, the range, y is greater than or equal to 0. All right? So far, so good? Good. Well, I'm going to stop here because we're getting to inverse functions next. So look at this, think about it, and realize, oh yeah, this is chapter 2 all over again. Any questions, shoot me an email. Otherwise, I'll see you in the next video. Good luck.